This video is Pandas tutorial. Pandas is a module used for data analysis. It helps us to work with tabular data. It helps us to manipulate, clean, remove duplicates, transform data, etc. So this video we will have a brief introduction to Pandas. If you're new to this channel, I'm Karina. I have transformed my career from finance to data, and I'll help others to do the same one step at a time. The name Pandas doesn't come from cute animal, it comes from panel data. It is a term for multi-dimensional structured datasets. Pandas can work with different types of data. It can work with CSV, Excel, and JSON format data. The very first step, you need to install the library into your machine. So when you start working with a new module, you need to install it. To install it, we say !pip install and name of the library. Then you need to run this line of code. In Jupyter Notebooks, this is the button you need to click. This action will install the module into your machine. You will see that the process is complete, and then you can import the library into your file that you're working with. So every time you start in a new project, you start in a new file, you need to import the module, but you don't need to install it because it was installed before into your machine. To import the module, we say import pandas as PD. In this case, PD is alias we give to this module. This alias allows us to refer to our module simply as PD instead of typing out the full name of Pandas each time. As I mentioned before, Pandas can work with tabular data, with our Excel spreadsheets. Pandas syntax is very simple when we want to read our files. We need to give a name to our dataset. Usually I say df, some people say data, some people use more descriptive names, for example, sales underscore data or user data. I just use df. Then we say equal, and then we say pd dot, which is we're referring to our pandas, read underscore CSV or Excel. In the brackets in quotes, we need to indicate the path to our file. I found this new dataset at kaggle.com, customer purchase dataset, and we will be working with that. Let's execute these lines of code. Then you can either print the whole dataset, then you just need to say df and then print it, or we can select which rows we want to print. For example, if you want to print top 5 rows of your dataset, we use the syntax .head. We say name of our data frame or df .head brackets. This way we displayed 5 top rows of our dataset. I mentioned before that df is alias. If we didn't use the alias, our syntax will look like pandas.dataframe.head empty brackets. It is long, that's why people prefer to give alias to the module, so we don't need to write this long way. With this line of code, we read our CSV file because our data is saved as CSV. If you needed to read Excel file, we say read underscore Excel. You can also read JSON files, and this is the most basic syntax for reading files. But there are other parameters that can be added when you read a file. For example, you're working with a huge file, you can't read it in one go, then you need to chunkinize it. So you need to create various chunks of your data, for example 100,000 rows, and read it bit by bit. Also in a read underscore CSV, read underscore Excel, you can indicate which specific columns you want to read. If you don't want to use the whole data set and you want to work, for example, with 2-3 columns, you can indicate that. You can indicate how many rows you want. You can indicate what rows you want to skip. Some datasets in Excel especially might have a logo of the company as first or second row, and you don't want to work with that, so you can say skip first to second row and start reading the file afterwards. So the parameters you can indicate is like delimiter, what rows to skip, what will be your very first column if you want to read, for example, from the column number 3 onwards. You can indicate how many rows you want to read if you want to see only 1,000 rows, not the whole file. You can indicate which parameter to replace missing values. This is an example of what other parameters can be included in our read underscore CSV. You can find all these details in the official Pandas documentation. I will link in the description to this video. Also, I created a Pandas cheat sheet where I put all my knowledge, where I put how to read files with different parameters. This example is actually from that cheat sheet. Also, how to manipulate different data sets, merge, join, transform, how to work with indices, how to visualize your data. So if you're interested, also link in the description, you can get your Pandas cheat sheet. When we say df.head empty bracket, we view top 5 rows of our dataset. But if you want to see not 5 but 10 or 15 rows, you need to indicate that number in the brackets. For example, we can say df head 15, and now we've used top 15 rows of our dataset. If you want to see bottom rows instead of top rows, for example, your data is sorted from the earliest date to the latest date, and you want to see what was the latest date in my dataset, you can view 5 last rows of your dataset. To do that, we use dot tail. So similarly, we say df dot tail empty brackets. Again, by default, empty brackets gives you 5 rows, and if you want to change the number, you can indicate that number within those parentheses, within those brackets. If you want to check your data for missing values, we say name of data frame df dot is null empty brackets dot sum empty brackets, and this will provide you a list of all the columns in your data set and how many missing values each of those columns have. In our case, there are no missing values because we can see zeros for each of the columns. In case you had missing values, you would see some number, how many of those missing values there are. And to view basic statistics of our dataset, we use .describe. Name of our data frame .describe empty brackets. And this gives you the statistics about your datasets. Count means how many rows each of the columns have, and then mean is the average, standard deviation, minimum, maximum, and this percentile. This is very useful when you need to quickly summarize the findings about your dataset. So in our case, we can say that the column age varies from age of 18 up to age of 64. So you already have this data here, and you just write it down in your summary report. When we said .describe empty brackets, we got the data only for numeric columns. In case you want the data for all the columns, then in the brackets you need to say include equals all. In this example, all the data, all the columns are numeric, but in case you had some non-numeric, for example, names of countries or cities, names, those columns wouldn't be included in this .describe empty brackets, but they would be shown in this when we say include equals all. Let's look at other basic data frame properties. For example, .shape, we say df.shape, there are no brackets. In this case, it shows us how many columns and how many rows we have. The first number is number of rows, the second number is a number of columns. Other way to see how many rows we have, we can say len and then in brackets df. If you want to see total number of elements, we can say .size, and this is number of rows multiplied by number of columns. If you want to see row and column labels, we can use .axis, and now you can see all the names of our columns. Another way to see the columns, we need to say .columns. So we say df.columns, again no brackets. It also provided us the list of all our columns available in our dataset. In case you want to rename columns, we need to say df.rename brackets. In the brackets, you say columns equal and then curly brackets. Curly brackets means you are creating a dictionary. Dictionary is a data type in Python, and dictionaries always have key value pairs. The first part before the colon is our key, and the second part is a value. In this case, we say what it was and what it should be. So find what, rename with what. In our case, for example, we want to rename spending score as this way, membership years this way, and you create this dictionary of all the values how you want to rename, and then you say comma in place equals true. So you want to replace those values, that's why we say in place equals true. And if you run this line of code, we will rename our columns. Let's have a look how can we create a new column in our data frame. For example, you need to make some calculations. In our dataset, we have spending score and membership years. Let's create a new column called a spending per year, and spending by year will be spending score divided by membership years. To create a new column, we say name of our data frame square brackets, and in the square brackets name of the new column we are creating. When you need to refer to a column, we always use square brackets, and in the square brackets quotes in quotes the name. So we are creating a new column called a spending per year equals, and then we need to indicate our calculation. Our calculation will be we use our spending score column and we divide it by membership years. And division in programming in Excel is always a slash. Let's run it, and now if you look at df.head, we can see we have this new column that we've just created. Let's create a new dataset, new data frame. We will call it df_filtered. Again, you can use whatever name you would like, equals df square brackets, and then in the square brackets you are indicating condition for your filtering. For example, we want to filter where the value in the column h is greater than 30. So we say df square brackets h, because we need to reference to our column, more than 30. And because 30 is an integer, integers don't need to have any quotes around it, but when we use strings, for example, name of the country, then we have to use quotes around it. Let's say df filtered and printed. This new dataset df filtered has 1102 rows, so of course we filtered our data, and you can see that h value is always more than 30. If you want to filter your data by several conditions, the syntax will look like this. It also starts with df square brackets as above, but your condition need to be surrounded by the brackets, and then we use this @ sign to say this condition and the next condition. For example, we say that we want to filter our data where the age is more than 30 and at the same time where membership years equal 10. To say equal, we say equal in Python because one equal sign is used as an assignment operator. For example, here when we were creating a new data frame or when you create a new variable, you say name of the variable equals value. And because of that, we have to use double equal sign when we want to say that something equals something. That's why in this case we said equal 10. Let's run it. And now we have only 70 rows and age is all above 30 and membership years equal 10. And this way we just displayed our data, but if you want to save it, if you want to work with this dataset further, you need to assign it. So again, you can say df filtered by age and years, or come up with a better name, equals, and then this. In that case, you will assign these results to that variable and you can work further with that. For example, if you want to visualize it or you want to export it. In Python, we can also sort our data. To sort data, we say name of data frame or df dot sort underscore values brackets. In the brackets, we indicate what we are sorting by, in our case income, and then you need to say ascending, false or true. So if you want to sort it from smallest to largest or largest to smallest. So you can see that we sorted our data by income from largest to smallest. Let's dive into some more advanced features that will make your analysis more powerful. For example, there is group by in Pandas. And grouping by is kind of similar to pivot. There is also pivot in a Pandas, but let's start with group by. So you group in your data by specific value, and then you say how you want to aggregate the values in the data. For example, we are creating a new data frame. We will call it group by age equals name of the data frame df dot group by brackets. In the brackets, we are indicating what are we grouping by. We are grouping by age. .agg brackets, in the brackets curly brackets. And as I mentioned before, curly brackets are used to create a dictionary. And why are we doing it? Because we want several columns and they will be grouped differently. For example, we want average for our income. So we say column income, aggregation will be mean or average. Membership years, we want to get maximum, and for last purchase amount, we want to get sum. I just wanted to show you what is possible. We can aggregate average, which is mean, max, minimum, and a sum. And then when we close our brackets, we can say that we want to round our data for 2 decimals. And to do that, we say dot round, and in the brackets, we say 2. And let's display the results. So we say group by age. You can see that we grouped our data by age. So our rows are age, and then we have 3 columns that we indicated: income, membership years, and last purchase amount. And membership years is maximum, purchase amount is sum, and this is the average income. We can also pivot our data. Pivot data is basically multiple grouping by, so it is more advanced. Usually if your data is very simple, you start with group by and then you move into pivot territory. Let's create a new data frame which we call pivot by age. We say pivot by age equals df.pivot table brackets. Then we need to indicate what will be our values. Our values will be income. Then you say columns. I want membership years as my columns. So the row will be income, and then this income will be displayed for each of membership years. How do we want to aggregate function? I want maximum income. It can be total, average, minimum, again up to you. And fill value equals 0. So if you have missing values, we are filling it in with 0. And let's display our values. This is the values. As you can see, we have values for income. It is aggregated as max, so max income, and our columns is our membership years. And in the previous example, we used values, but we didn't use index. Let's add the index parameter. So index will be also our rows. It will remind you pivot table in Excel. Let's rerun it and let's print the data. So now you can see that in this case, we indicated index, which will be our rows. In our case, it is age. Our columns is membership years, and the values in each of these cells is income, and it's displayed as a maximum value. Let's also have a look today at basic analysis and grouping by categories and how you can derive some insights. For example, we want to see average spending score by age group. And to do that, we will bin our data. We will create a new column called age group. So we say df square brackets age group equals pandas.cut brackets. In the brackets, we are indicating what we are binning, what grouping we're creating for our values. We say it will be for age column, and then we indicate what bins we will have. So from 0 to 24, then 25 to 45, and this is the bins. So you need to give a cutout point and then the labels for each of the bins. So for example, bin will be less than 25, from 25 to 45, 45 to 65, and 65 plus. This is a great way to group your age data because we often work with this for analysis, or maybe you want to group your income as well in some bins, and this way you can do it. Let's print df head 10 rows to see this new column. So you can see now in the age group, we created those bins. So for example, this user aged 56 is now in age group 45 to 65. This user in the same group, 32 is in this group, etc. And now by using this column, we can calculate the average spending. So we say average spending equals df.group by, we are grouping by our age group, and we want to see average spending score. So again, we are grouping by age group, and our value will be average spending score. And this is results. So for each of the group now we can see what was the average spending score. If you're just starting with Python, I have a data analysis with Python masterclass where in 3 hours you learn how to work with Pandas, and we use a retail example to work with that file, and I go into more details of different data types and more functions. Also, you have home tasks to practice your skills, and we also talk about Matplotlib library in more details, how to create various types of visuals, when are they used. You can check out the masterclass link in my description. And the last thing we will look at today is to how to create a visual for your data. For simplicity, we will create a new data frame for the first 10 users. So we'll say first 10 customers equals df.head10, and we want only columns number and income. So you can see that we can use .head.tail to actually select top 10 or bottom 10 of our customers, and then you can assign this value to another value and use it further, for example, for visualization. So again, we say df.head10 because we want 10 customers, the very first 10 customers, and here we indicate which specific columns we want. I don't want all the columns, I want only number and income. So to indicate which columns you want, you use square brackets. Since we want not one column but several columns, we need to create a list of columns. In Python, lists are created by using square brackets. So list is another data type, and that's why we say square brackets. In the brackets we say number and income. Let's run it. I will show you how this data looks like. So we just have 2 columns, number and income, only 10 users. We will set the index for better labeling, and to set index we say name of the data frame. In our case it is first 10 customers dot set underscore index brackets. In the brackets we will say that we will use column number as our index, and that's why we say in place equals true. So let's run it and let's rerun this code and you see how it will change. So at the moment we have index and then number income. Okay, now the index disappeared because we use number as our index. And the last part, let's quickly create a visual for your data. First of all, we need to import matplotlib.pyplot as PLT. This is a module that we will be using for visualization. So if it's the first time you are working with this module, you need to install it into your machine. So again, exclamation mark pip install matplotlib, run that line of code, then run this line of code. And now let's create a visualization. So we say name of our data frame. In our case, it is first and customer, square brackets. We need to indicate what we're visualizing. We want to visualize our income. Dot plot brackets. In the brackets, we need to select the type of our chart or kind of our chart. We will do a bar chart. You can also create a line graph or pie chart. There are different types of charts in this module. We will be working with bar chart. Color equals light blue. That's the color of our visual, and fixed size 8x5. This is the heights and widths of our visual. You can make it bigger or smaller. plt.title, this is the title of our chart. In our case, it will be income by customer. .xlabel, .ylabel. With this, we are adding labels to our x-axis and y-axis. So it will be customer number for x label, income for y label, and plt.show empty brackets to display your visual. Let's run it. And this is the results. So income by customer is our title, and now you can see titles for X and Y label, and of course the income for first and customers. This was a brief introduction into Pandas. Let me know if you're interested and we can create part 2, part 3 of this series, and I can go into other functions available for Pandas.